So in a survey, U.S. adults were asked to identify which social media platform they use, where 37% responded that they use Instagram. If 6 of these who participated in the survey are asked if they use Instagram, find the probability that exactly 2 say yes. So when we're working with these binomial probabilities, the first thing that you always want to do is just identify the pieces that we're working from. Here, we're talking about 6 people in a survey. So our number of trials here is n equals 6. And we're told that 37% use Instagram, where we are looking specifically for people that do. So P is equal to 0.37, which means that Q, that is someone not using Instagram. This is binomial because either you do or you don't, but it's kind of benign, like I said, is 0.63, where X is defined as a person using Instagram. Like I said, not really the most successful thing in the world, maybe influential if you were, but a success here doesn't always mean a good thing, like I said. So here is our scenario. If we want to find that probability, we can just use that formula. We want to find the probability that X is exactly 2. We have exactly 2 people in that group of 6. Well, we have 6 of them and have to pick 2. Each of those 2 has a 37% chance of being as we want. And then the remaining 4 all have associated probability 0.63. So take these pieces, multiply them out, and what we get as a result is a probability of, I should say, not equal, approximately 0.323. So about a 32% chance of happening. But let's say we want to do this with a bit more detail. Let's say that instead of looking for the probability of exactly 2, what if we want at most 2? Or for that matter, more than 2. Well, we would have to understand here that if we're looking for the probability of at most 2, that means we need the probability of none, or the probability of 1, or the probability of 2 using the addition rule, where thankfully these are disjoint events because these are all discrete pieces, but even so, that means we gotta do something in that flavor for this, something in that flavor for this, and something in that flavor for that, which we've already done, but still, 3 pieces, and 3 is a lot. When this sort of thing is actually what the calculator is really well designed to handle with something called a CDF function, where this guy up here used the PDF type function. That's the sort of thing I'll talk about a little bit at the end. We're going to see a lot more of in chapter 5. But the point is, here, yeah, you can do it by hand, but you'd really be better off seeing how the calculator does it. And for that matter, if you want to get more than 2, the probability that X is greater than 2, well, that would be 3 or 4 or 5 or 6. And besides the fact that this is even worse, it's also not the sort of thing that your calculator is great at handling. I'll explain that in a different video. But really what you should do here is understand that in this context, more than 2 is the opposite of at most 2. So if you need more than 2, you're generally better off looking in terms of that as the complement for at most 2. really this is the long way of handling things without a calculator. Really, you want to get good with it. In any case, the next thing we're going to look at here is some of those properties we can talk about with the binomial distribution. In particular, we're going to look at what happens in terms of means and standard deviations, and along the way, variance.